Did you know that if the bloop were real, it would be larger than any animal that has ever existed on Earth, including the largest known dinosaurs? This hypothetical sea monster would stretch over 350 meters long. That's more than 3 times the length of a blue whale. In the next few minutes, we're going to explore the fascinating world of marine biology, pushing the limits of what's possible in nature. We'll design a scientifically plausible version of the bloop, complete with unique adaptations that could allow it to survive in the crushing depths of the ocean. Join us as we explore the boundary between science and science fiction. In the summer of 1997, an eerie sound reverberated through the depths of the Pacific Ocean, captivating scientists and sparking a mystery that would endure for years. This unexplained acoustic phenomenon, later dubbed the bloop, defied conventional explanations and set off a chain of investigations that would challenge our understanding of underwater acoustics. The bloop was first detected by the National Oceanic and Atmospheric Administration's NOAA sophisticated underwater listening system. This network, known as the Equatorial Pacific Ocean Autonomous Hydrophone Array, consists of highly sensitive hydrophones strategically placed across the Pacific. Originally developed to help the U.S. Navy track submarines during the Cold War, the system now serves as a vast acoustic surveillance net for various scientific purposes. What made the bloop so enigmatic was its unusual characteristics. The sound was recorded as an ultra-low frequency event that lasted for about 1 minute. Its sheer power puzzled scientists, as it was picked up by multiple hydrophones in the NOAA array, an uncommon occurrence for underwater sounds. NOAA scientist Christopher Fox, one of the first to analyze the recording, was particularly intrigued by the bloop's sound profile. He noted that it bore a resemblance to sounds produced by living creatures, but with one crucial difference: its volume far exceeded anything known in the animal kingdom. Fox stated, "This sound was far more powerful than the calls made by any animal on Earth. Even the vocalization of a blue whale, the largest animal ever known to exist, paled in comparison to the bloop's intensity." The unprecedented loudness of the bloop raised intriguing questions about its source. If it was indeed produced by a living creature, what kind of animal could generate such an enormously powerful sound? And if not biological in origin, what other phenomena could explain such an acoustic anomaly? Adding to the mystery was the vast distance over which the bloop was detected. As Bob Ziak from NOAA remarked, "It's unusual when a sound is recorded on all of the sensors we have deployed." This wide-ranging detection suggested that the source of the bloop was not only incredibly loud, but also capable of projecting sound over immense distances. The location of the bloop's origin added another layer of intrigue to the mystery. Scientists triangulated the source to a remote area of the southern Pacific Ocean, approximately 1,087 miles off the coast of Chile. This region, known for its extreme depths and relative isolation, fueled speculation about what could be lurking in the unexplored abyssal plains of the ocean. As we peer into the abyss, a startling question emerges. What if the bloop wasn't just a sound, but a call? The notion of an undiscovered sea monster may seem far-fetched, yet our limited knowledge of the deep ocean leaves room for speculation. How large would a creature need to be to produce such an earth-shaking noise? The concept of marine cryptids, or undiscovered sea creatures, has long captivated the human imagination. From ancient tales of sea serpents to modern-day sightings of supposed prehistoric survivors, our oceans have been a fertile breeding ground for myths and legends. However, the bloop presented a unique challenge to marine biologists and cryptozoologists alike. Its sheer power and range defied explanation by any known animal, leading some experts to entertain the possibility of an as-yet undiscovered giant lurking in the depths. Speculation about the bloop's biological origin centered around the size requirements for a creature capable of producing such a sound. Based on the characteristics of the recorded noise, Some experts suggested that the hypothetical animal would need to be significantly larger than the blue whale, the largest known creature to have ever existed on Earth. While blue whales can reach lengths of up to 100 feet and produce vocalizations reaching 188 decibels, estimates for the bloop source suggested a creature potentially over 250 feet long, with an acoustic output far exceeding that of the blue whale. Recent discoveries of large marine species have fueled speculation about the existence of other undiscovered creatures. The vast, unexplored abyssal plains and trenches of the world's oceans could potentially harbor life forms that defy our current understanding of marine biology. However, the biological origin theory for the bloop faces significant challenges. The energy requirements for a creature of such immense size would be staggering, raising questions about its feasibility in the food-scarce deep ocean environment. Moreover, the lack of physical evidence and the improbability of such a massive animal remaining undetected by modern technology weaken the case for a biological source. While the ocean depths still hold many secrets, the existence of a creature large enough to produce the bloop stretches the boundaries of biological plausibility. As we sail away from biological explanations, we drift into waters where reality and fiction intertwine in the most unsettling way. What if the bloop's true nature lies not in the realm of zoology, but in the twisted imagination of one of horror's greatest minds? The coordinates of this mysterious sound tell a story that would make even the bravest sailor's blood run cold. H.P. Lovecraft, an American writer of weird and horror fiction, created a mythos centered around Cthulhu, an ancient, slumbering deity of unfathomable power and terror. Lovecraft's stories describe Cthulhu as a colossal entity imprisoned in the sunken city of R'lyeh, hidden beneath the Pacific Ocean. The bloop's origin was triangulated to approximately 50 degrees south, 100 degrees west, a remote location in the southern Pacific Ocean. Remarkably, this point is a mere 1,760 kilometers away from the coordinates Lovecraft specified for R'lyeh: 47 degrees, 9 minutes south, 126 degrees, 43 minutes west. The proximity of these two locations is nothing short of uncanny, especially considering the vast expanse of the Earth's oceans. This geographical coincidence ignited the imaginations of Lovecraft enthusiasts and conspiracy theorists. Some speculated that the bloop might be the sound of Cthulhu stirring in its slumber, the creaking of R'lyeh's otherworldly architecture, or even the psychic echoes of Cthulhu's dreams. These theories, while captivating, remain firmly in the realm of speculation. The Lovecraftian connection to the bloop is not an isolated incident of reality mirroring fiction. Other elements of Lovecraft's work have found eerie parallels in the real world, such as his descriptions of non-Euclidean geometry, predating similar concepts in modern theoretical physics by decades. However, the scientific community has remained understandably skeptical of any supernatural explanations for the bloop. Robert Ziak, a NOAA researcher, addressed these theories directly, explaining that the perception of the bloop as an animal sound was influenced by how it was played back, which made it resemble an animal vocalization rather than its true nature. While the coincidence is indeed remarkable, scientists emphasize that correlation does not imply causation, and that more prosaic explanations should be explored before entertaining fantastical theories. As researchers turned away from fantastical explanations, they found themselves drawn to the icy reaches of the Antarctic. What if the key to unlocking the bloop mystery lay not in the depths of the ocean, but in the colossal movements of ice sheets? This shift in focus brought scientists face to face with one of Earth's most powerful natural phenomena: ice calving. Ice calving occurs when chunks of ice break off from glaciers or ice shelves in polar regions. These events can range from small breaks to massive collapses that release icebergs the size of cities into the ocean. When large masses of ice separate, they generate low-frequency sounds that can travel vast distances through water, much like the bloop. Initially, the idea that ice could be responsible for the bloop was met with skepticism. How could cracking ice produce a sound powerful enough to be detected by hydrophones over 3,000 miles apart? The ocean is filled with natural and artificial noises, making it challenging to distinguish the unique signature of ice calving. However, as scientists studied ice acoustics, a compelling case emerged. research revealed that ice-related events, known as icequakes, occur frequently and intensely in the Antarctic region. The largest of these events can generate sounds that rival or even surpass the volume of the bloop. Climate change has increased the frequency and power of these ice-related sounds as warming temperatures destabilize ice shelves and glaciers. A key breakthrough came from NOAA's acoustic survey of the Bransfield Strait and Drake Passage in 2005. This study showed that ice-related noises are a dominant source of natural sound in the Southern Ocean, with characteristics matching those of the mysterious bloop. As evidence accumulated, a scientific consensus formed around the glacial origin of the sound. The location of the bloop's origin was refined to areas known for significant ice calving activity, providing geographical support for the hypothesis. This correlation, combined with acoustic similarities between ice calving events and the bloop, offered compelling evidence for the glacial explanation. The journey from the bloop's initial detection to its identification as an ice-related phenomenon spanned nearly a decade. Advancements in underwater acoustic technology and our understanding of polar environments were crucial in solving the mystery. The resolution of the bloop enigma demonstrates the power of scientific inquiry and the importance of considering all possible explanations, even those that might seem ordinary compared to more sensational theories. As one mystery concluded, another began to unfold. The NOAA's pursuit of the bloop's origin revealed an unexpected twist. The sound that captivated the world was just the tip of the iceberg. What other secrets lay hidden beneath the waves, waiting to be discovered by those willing to listen? The investigation into the bloop's origin presented NOAA scientists with formidable challenges. The vastness of the largely unexplored ocean, combined with limited initial data, made pinpointing the sound's source a daunting task. Scientists faced searching an area spanning thousands of square miles in remote regions of the southern Pacific Ocean. Undeterred, NOAA researchers embarked on a series of expeditions to gather more data. These missions involved deploying additional hydrophones, conducting sonar surveys, and analyzing water samples for unusual biological or chemical signatures. Each expedition brought new data and questions. As the bloop's origin remained elusive, technological advancements played a crucial role in the investigation. Improvements in underwater acoustic monitoring systems allowed for more precise triangulation of sound sources, while advanced signal processing algorithms helped isolate specific acoustic signatures. These innovations significantly narrowed down potential sources of the bloop. The investigation faced setbacks and false leads. Early speculation about biological origins led to extensive marine life surveys, while theories about underwater volcanic activity prompted detailed seafloor mapping expeditions. Although these efforts yielded valuable data for oceanography, they did not solve the mystery at hand. As years passed, the bloop investigation intersected with other areas of oceanic research. Studies of climate change impacts on polar ice, advancements in ocean acoustics, and improved seismic activity monitoring all contributed pieces to the puzzle. Scientists began to notice patterns hinting at a connection between the bloop and large-scale ice movements in the Antarctic region. The breakthrough came in 2005 when NOAA initiated a focused acoustic survey in the Bransfield Strait and Drake Passage. This 5-year study provided the key evidence that would ultimately solve the bloop mystery. By comparing the acoustic signatures of various ice-related phenomena with the original bloop recording, researchers identified striking similarities in frequency, duration, and characteristics. The culmination of this decade-long scientific odyssey was the realization that the bloop was part of a larger acoustic phenomenon generated by the movement and breakup of polar ice sheets. This discovery not only solved a long-standing mystery, but also opened up new avenues for studying climate change impacts on polar regions through acoustic monitoring. The bloop's true identity as ice calving opened a portal to an underwater world filled with sound. But just how noisy is this icy realm? Imagine thousands of frozen earthquakes shaking the Antarctic seas each year, a cacophony that could hold the key to understanding our planet's changing climate. Antarctica's ice shelves are the composers and performers of a constant, thunderous underwater orchestra. The scale and frequency of ice calving events in this region create a sonic landscape that is as vast as it is dynamic. Each year, These icequakes resound through the Southern Ocean, generated by the cracking, shifting, and breaking of massive ice formations. The volume and range of these ice sounds are truly astonishing. When a large chunk of ice breaks away from a glacier or ice shelf, it can produce a noise that rivals the loudest sounds on Earth. Some of the largest ice calving events have been recorded at volumes exceeding 220 decibels underwater, louder than a rocket launch. As temperature changes cause ice to expand and contract, stress builds up within the frozen mass. When this stress exceeds the ice's structural integrity, it releases in a sudden, explosive crack. This creates vibrations that translate into low-frequency acoustic waves in the water, which can travel enormous distances underwater, sometimes propagating for thousands of kilometers before dissipating. This long-range acoustic propagation is why events like the Bloop can be detected by hydrophones across vast stretches of ocean. It's a remarkable example of how the physical properties of water and sound interact to carry information across the globe's watery expanses. The constant barrage of ice-related noises contributes significantly to the overall acoustic environment of the Southern Ocean, creating a background hum that marine life and researchers alike have come to recognize as the voice of the Antarctic. Among these numerous ice sounds, some stand out for their sheer magnitude. The largest known ice calving events, such as the collapse of the Larsen B ice shelf in 2002, produce sounds that dwarf even the mysterious Bloop in scale and power. These massive calving events can release icebergs the size of small countries, generating acoustic signatures that reverberate through the ocean for days or even weeks. In this context, the Bloop fits into a larger acoustic phenomenon, a single, albeit impressive note, in an ongoing Antarctic symphony. What once seemed like an anomalous sound is now understood as part of the natural acoustic repertoire of our planet's frozen regions. The Bloop's volume and low frequency, once thought to be indicative of an unknown marine creature, align perfectly with the characteristics of a significant ice calving event. While the Bloop may have lost its monster status, it has gained a new, perhaps more chilling identity. Could this powerful acoustic event be the harbinger of a global shift, echoing the accelerating melt of Earth's ice sheets? As we tune into these frozen symphonies, we might be hearing the first movements of a climatic opus that will reshape our world. The connection between ice calving events like the Bloop and climate change is becoming increasingly clear. As global temperatures rise, the stability of Antarctic ice shelves is compromised, leading to more frequent and larger collapses. These ice shelf breakups represent a broader trend of accelerating ice loss in polar regions. Warming oceans play a crucial role in destabilizing Antarctic ice. As sea temperatures rise, they erode the ice shelves from below, weakening their structure and making them more prone to collapse. This process creates a feedback loop. As more ice breaks away, it exposes more of the ice shelf to warmer waters, accelerating the melting process. Projections for future ice loss in Antarctica are sobering. If current trends continue, scientists estimate that sea levels could rise by over 1 meter by the end of the century. This rise would be largely due to the melting of Antarctic ice, with each major calving event contributing to the overall increase. The global implications of this accelerated ice loss are far-reaching. Rising sea levels threaten coastal communities worldwide, potentially displacing millions of people. Changes in ocean circulation patterns, driven by the influx of fresh water from melting ice, could have profound effects on global climate systems. Marine ecosystems, already under stress from warming waters, face further disruption as their physical environment undergoes rapid change. As ice shelves collapse and melt, they destabilize the glaciers behind them, leading to increased rates of ice flow into the ocean. This process further exacerbates sea level rise and alters the dynamics of polar ecosystems. The sounds of these massive ice movements, once rarities like the Bloop, may become more commonplace, serving as an acoustic record of our changing planet. The Bloop, once a mysterious anomaly, has now become a potent symbol of climate change. Its transition from an unknown monster to a recognized ice event parallels our growing understanding of the urgent environmental challenges we face. The sound that once captured our imagination now captures our concern, reminding us of the dramatic changes occurring in Earth's polar regions. While the Bloop's origin has been demystified, The oceans continue to speak to us, but their message is becoming increasingly garbled. In recent decades, a new phenomenon has been drowning out the natural symphony of marine life, potentially masking crucial ecological signals. This invisible intruder is none other than human-made noise pollution, a growing concern that's dramatically altering the acoustic environment of our oceans. The concept of ocean noise pollution may seem counterintuitive at first. After all, we often think of the deep sea as a silent realm, far removed from the cacophony of human activity. However, beneath the waves, a complex and vital soundscape exists, one that marine life has evolved to depend on for millions of years. This underwater acoustic world is now under threat from an unprecedented surge in man-made noise. The sources of this artificial din are numerous and diverse. Global shipping traffic, with over 90% of world trade carried by sea, generates a constant low-frequency background hum. Oil and gas exploration activities, such as seismic surveys, produce intense bursts of sound that can exceed 230 decibels. Military activities, including sonar systems and underwater explosions, further contribute to the acoustic assault on marine ecosystems. The scale of this acoustic invasion is staggering. Anthropogenic sounds have increased dramatically since the 1960s, with low-frequency noise showing the most significant rise. In some regions, this background noise has effectively doubled in intensity every decade, fundamentally altering the ocean's soundscape. The consequences for marine life are profound and far-reaching. Many species rely heavily on sound for communication, navigation, and finding food. Whales and dolphins, for instance, use complex vocalizations that can travel for hundreds of kilometers. The increasing background noise is shrinking their acoustic space, forcing them to adapt their communication patterns or shout to be heard over longer distances. For species that use echolocation, like many cetaceans and some fish, the problem is even more acute. As ambient noise levels rise, their ability to interpret echoes for navigation and prey location is compromised, potentially affecting their hunting success and overall survival. The impact extends beyond communication and navigation. Increased noise levels can lead to chronic stress in marine animals, affecting their immune systems and reproductive success. Some species have been observed altering their migration routes to avoid noisy areas, potentially disrupting entire ecosystems. Perhaps most concerning is the potential for masking important natural signals. Phenomena like the bloop, once easily detectable, could become increasingly difficult to identify amidst the growing background noise. This masking effect doesn't just impact scientific research. It could have serious implications for marine life that relies on detecting subtle acoustic cues in their environment. As the cacophony of human-made noise threatens to drown out the ocean's secrets, scientists are fighting back with an arsenal of cutting-edge technology. What if we could not only hear the faintest whispers of marine life, but also decode the very language of the sea? Recent breakthroughs in acoustic monitoring are promising to unveil mysteries that have eluded us for centuries. At the forefront of this technological revolution are advanced acoustic monitoring systems developed by organizations like NOAA's Pacific Marine Environmental Laboratory, PMEL. These tools capture and analyze long-term data sets of the global ocean acoustic environment with unprecedented precision. They can operate autonomously for extended periods, providing continuous streams of high-quality acoustic data from even the most remote corners of our oceans. The sheer volume of data generated by these systems presents its own set of challenges. Distinguishing meaningful signals from the ever-present background noise has become increasingly complex. This is where artificial intelligence is making significant inroads. Advanced algorithms sift through massive acoustic datasets, identifying patterns and anomalies that might escape human analysts. These AI-powered systems recognize and categorize a wide range of underwater sounds, from the vocalizations of known marine species to the rumblings of submarine volcanic activity. They can detect subtle variations and unique acoustic signatures that might indicate the presence of previously unknown phenomena or species. This capability is particularly crucial in an era where noise pollution is making it harder to isolate individual sounds in the oceanic soundscape. The applications of these technologies extend far beyond simple sound detection. Algorithms are being trained to interpret complex acoustic data, potentially allowing scientists to translate the communication of marine animals. This could enable researchers to decipher the nuanced dialects of different whale pods or understand the intricate acoustic behaviors of deep-sea creatures we've never even seen. Recent discoveries made possible by these advancements are already reshaping our understanding of marine ecosystems. New species of beaked whales have been identified solely through their unique vocalizations, while the migration patterns of elusive deep-sea creatures have been tracked, providing insights into behaviors that were previously impossible to observe. The potential for future breakthroughs is even more exciting. Researchers are working on systems that could potentially predict seismic events by detecting subtle changes in the ocean's acoustic environment. Others are developing acoustic monitoring networks that could provide early warnings for approaching tsunamis or track the movements of massive underwater currents that influence global climate patterns. These technological advancements might also help solve other long-standing ocean mysteries. The ability to listen more closely and intelligently to the ocean could lead to discoveries about the Bloop's less famous cousins, other unexplained underwater sounds that have puzzled scientists for years. From the upsweep to the whistle, these acoustic anomalies might finally find explanations through the application of these cutting-edge technologies. The Bloop's mystery has been cracked, but it has opened the floodgates to a sea of new questions. With over 95% of Earth's oceans still unexplored, what other colossal secrets might be lurking in the abyss? Recent discoveries suggest we've only scratched the surface of the ocean's enigmas. Despite the Bloop being solved as an icequake, NOAA continues to record numerous unidentified sounds in the ocean, indicating that many mysteries remain. These unexplained acoustic phenomena range from low-frequency rumbles to high-pitched whistles. Examples include the upsweep, a series of narrow-band sounds detected in the Pacific Ocean since 1991, and the whistle, a high-pitched noise recorded in the Mariana Trench. These acoustic anomalies highlight the vast gaps in our understanding of the ocean's soundscape and the potential for groundbreaking discoveries. The extreme pressure, darkness, and remote nature of deep ocean environments make traditional exploration methods difficult and costly. However, advancements in technology are opening new avenues for research. Autonomous underwater vehicles equipped with sensitive hydrophones can now venture into the abyss, capturing long-term acoustic data without human intervention. These technological improvements are crucial in overcoming the challenges of deep-sea exploration. Ongoing investigations into unidentified sounds are providing valuable insights into the health and dynamics of marine ecosystems. By analyzing these acoustic signatures, scientists can monitor changes in biodiversity, track the movements of elusive species, and even detect early warning signs of geological events like underwater earthquakes or landslides. Recent unexpected discoveries underscore the potential for future revelations. In 2021, a previously unknown species of beaked whale washed up on a beach in New Zealand, reminding us that even large marine mammals can evade scientific detection. This finding suggests that some unexplained ocean sounds could be attributed to undiscovered species, potentially as large and enigmatic as the creature once imagined to be the source of the Bloop. The methods used to solve the Bloop mystery are now being applied to study other unexplained sounds in the ocean. NOAA has been conducting ongoing acoustic surveys in regions like the Bransfield Strait and Drake Passage to better understand the sounds produced by icequakes and other natural phenomena. These surveys are not only helping to classify known sounds, but also to identify new acoustic signatures that may lead to future breakthroughs. The potential for future revelations in ocean acoustics is immense. As our ability to capture, process, and analyze underwater sounds improves, we may uncover patterns and phenomena that reshape our understanding of marine life and ocean dynamics. From decoding the complex vocalizations of deep-sea creatures to mapping the acoustic fingerprints of underwater geological processes, each new discovery has the potential to open up entirely new fields of study. As we conclude our journey into the depths of ocean acoustics, we're reminded of the vast mysteries that still lie hidden beneath the waves. The Bloop's revelation as an ice-calving event underscores the importance of continued research in marine environments. Each unexplained sound could be the key to understanding our planet's changing climate or discovering new species. Supporting ocean science and conservation is crucial for unraveling these enigmas. By funding research, reducing noise pollution, and protecting marine habitats, we can ensure that the ocean's secrets are preserved for future generations to explore. With over 95% of Earth's oceans still unexplored, countless incredible discoveries await us in the silent depths.